This is my intermediate algebra course. Today we're going to continue to learn how to graph quadratic expressions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, in the last class, the previous two classes, we graphed parabolas by plotting the vertex, and we used an x value to plot the other point by plugging in the x value and finding the corresponding y value. And then we used symmetry to find a third set of coordinates, and we connected the dots. And we're going to continue with that practice today. But we're going to also draw the line of symmetry, and we're going to write the equation of the line of symmetry. And in the previous classes, I sometimes required you to find x-intercepts and sometimes y-intercepts. But in this class, I'm going to require you to find both the x-intercept and the y-intercept in every single problem. And so we're just expanding on the things that we learned in previous classes. But before we do that, we're going to have to review how to graph horizontal and vertical lines and write the equations of horizontal and vertical lines. We did this in my beginning algebra course, and we reviewed it in my geometry course. But we're going to review that today before we continue with quadratic expressions. So it says here, write the equations of the lines graphed below and identify their slopes. So this is a horizontal line, so the equation is going to be y equals -2. And the justification for that is in all the points on that line, here's some points to consider, and all these points on this line, the y value is the same for each point. The y values are all -2. So because the y value never changes, and it doesn't really matter what the x values are, the x values can be anything. This line goes in infinity to the left and to the right. So because the x values can be anything and the y values are always -2, we just say that the equation of the line is y equals -2, because y is always -2. Now let's write the slope. Now remember, the slope of a line measures the steepness of a line. So if the line is going up like so, then it's going to be a very big slope, because that's very steep. If the line is not so steep, then you might have a fraction slope. And if it's very steep going down from left to right, then it's going to be a big negative number, or actually technically a small negative number. And if it's flat, then the slope is actually going to be 0. So the slope for any horizontal line is 0. Okay, so on to the next problem. Now this is a vertical line over here for number 2. So we write x is equal to 1, 2, 3, 4. And the reason for that, again, is the same type of logic. All these points have the same x value. They all have 4 as an x value. So x is always equal to 4. And mathematicians have decided to use, again, these expressions to notate vertical and horizontal lines. Now the slope, if you recall from my beginning algebra course and my geometry course, the slope is actually undefined. Whenever you have a vertical line, the slope is undefined. And the reason for that is slope is the change in y over the change in x. So for example, if you have a point on the line here and a point over here, and you're trying to find the slope, then the slope would be the change in y, which would be this length, divided by the change in x, which would be this length. So it would be 2 over 3. But if you're talking about 2 points on a vertical line, there is no change in x. Change in x is just 0. There is a change in y. It's 2, but you're not moving horizontally. So you would get 2 over 0. Okay, now if you move this point out a little bit, then you'd have a change in x. The change in x would be 1, while the change in y would be 2. So the slope would be 2 over 1. But again, because all the points are on the line, there is no change in x. So you end up with 2 over 0. But remember, whenever you have 0 in the denominator of a fraction, it's considered to be undefined. It doesn't tell us anything. So That's how you graph vertical and horizontal lines. So go ahead and try number 3, and when you come back, we'll do it together. All right, we're back. So this is a horizontal line, so the equation of the line is, y equals 1. And the slope of any horizontal line is always 0. So if you got that answer, good job. All right, go ahead and try number 4, and when you come back, we'll do it together. All right, we're back. So this is a vertical line, so the equation is x equals -2. And the slope is undefined. So if you got those answers, good job. Okay, so now we're going backwards. Now we're going to, we're given the equation of the line, and we're told to graph the line. So this is y equals 2, so that's a line where all the points have a y value of 2. And we're told to write the slope, and of course the slope of any horizontal line is 0. Now over here for number 6, we have x equals -5, so that's all the way over here. All the points on this line have a x value of -5, and the slope is undefined. The slope of any vertical line is undefined. Okay, so I want you to try number 7, and when you come back, we'll do it together. All right, we're back. So we have x equals 1, so this is a vertical line because x is always equal to 1, and the slope is undefined. So if you got those answers, good job. Go ahead and try number 8, and when you come back, we'll do it together. All right, we're back. Y equals -4, so that's 1, 2, 3, 4. That's down there. And the slope is 0. That's true for any horizontal line. Okay, so if you got that answer, good job. Okay, so now we're going to continue where we left off. In the previous classes, we're going to graph quadratic expressions. And I want you to go ahead and take a screenshot. You see we have the 3 forms of a quadratic expression, and we have all the ways to graph the quadratic expressions in the 3 different forms. So go ahead and take a screenshot of this. And please take a screenshot of that if you haven't already. You should have all this in your notes already, but if you don't want to have to go back and access that, you can go ahead and take a screenshot. And it's best really to take a screenshot with your phone so you can have that in front of you without having to constantly turn pages on your computer, or whatever you would call that, go from one page to another page. Okay, so now we're going to graph quadratic expressions just like we did in the previous classes, except I'm going to require you to find the y-intercept and the x-intercepts for every graph. And also, we're going to draw the line of symmetry and write its equation. Now we have intercept form in this equation. And so let's go ahead and write the constants. Remember, the signs change for m and n. And we are using this form here, intercept form, because we can see the x-intercepts just by looking at it. So step 1 is to find the most important point on a parabola, which is the vertex. And to find the vertex, we first start by finding the x value of the vertex, and we're going to use that special formula that we always use when we have the intercept form. So we plug in m and n, and then divide by 2, and we get -1. All right, now we're going to find the y value of the vertex, and to do that we plug in the x value, which we just found, to the original equation. So -1 plus 3 times -1 minus 1. And just to be clear, that -1 came from there. So now we have, I don't really require you to show this because you really should know this by now without having to show the steps. and we get -8. But I'm just showing you the steps here just so in case you need to see these. But you should already know this basic math. So now we're going to do, let's go ahead and write the vertex. So the vertex is -1, -8. We could write a table over here, but I'm not going to do that. I'm kind of tired of writing tables, and that, you don't really have to do it that way. Instead, I'm just going to write the points. Okay, so step 2. Let's see. Step 2 is to find the y-intercept. And to do that, we're going to let x equal 0. Remember, to find the y-intercept, you let x equal 0. To find the x-intercepts, you let y equal 0. And so we're going to plug in 0 to the original equation. So y is equal to 2 times 0 plus 3 times 0 minus 1. And I'm going to color those, maybe I'll color them green. That's where I got that 0. So now we have -6, it looks like, because we have 2 times 3 times -1, which is -6. So the point is 0, -6. That's the y-intercept. Okay, so now we're going to step 3. And step 3, again, if you want to find the y-intercept, you let x equal 0. If you want to find the x-intercepts, you let y equal 0. So now we're going to use that same equation, but now we're going to let y equal 0 and then solve for x. But I just want you to know that we don't really have to do that, because this equation is in intercept form, so we can see the x-intercepts just by looking at it. But the logic behind this, again, we know the x-intercepts are -3 and +1. But the logic behind that is when you plug in -3 or +1, it makes this expression here 0, and therefore it works in the equation, so those must be x-intercepts. So in case you don't know what I mean by that, let's plug in -3 and see what happens. I explained this briefly in previous classes. So I plugged in -3 for x, and so now we get 2 times 0 times -4, and 0 times any number has to be 0, so you're just going to get 0. So it works. So that's why -3 is an x-intercept. If you do the same thing with +1, plug it in here, then you'll get 0 also. So we don't really have to set y equal to 0. We can just look at this equation and just see, the x-intercepts by looking at it. So we can just write the x-intercepts immediately. So they are -3, 0, and 1, 0. All right, so now we have pretty much everything we need. So let's graph the vertex. The vertex is -1, -8. So 1, and then 1, 2, 3, 4, 5, 6, 7, 8. And be sure to write your coordinates off to the left or to the right, because we're going to be drawing the line of symmetry right down the middle. And the y-intercept is 0, -6. So that is here. And the x-intercepts are -3, 0, and 1, 0. And there you go. So now we can go ahead and connect the dots and make our parabola. And remember, your parabola is not supposed to look like a V. It should have some kind of a rounded point down here. My parabolas look a little bit too much like V's. It doesn't have to be perfect, but should be a rounded part down at the bottom there. Now I just made it worse, but you get the point. Okay, so now let's draw the line of symmetry, and the line of symmetry is really easy because it always goes right through the vertex. It's a vertical line that goes right through the vertex, and the equation is, remember, a vertical line is, the equation is always x equals some constant, and the constant is always the x value of the vertex, -1 in this case. You see the blue highlighted there, it's always the x value of the vertex. Now, if you're graphing parabolas that go off to the left or to the right, that's not going to be true necessarily. But we're not going to graph those until you get to pre-calculus. Okay, so that's all we have to do. I forgot to mention here that we're finding the x-intercepts. I should probably notate that, so you can understand what each step, or the purpose of each step. Okay, so let's try one more of these before you try one on your own. Again, we have intercept form, so a is equal to -1, m is equal to 2, n is equal to 6. First step is to find the most important point, the vertex. And whenever you have intercept form, we always use that equation to find the x value of the vertex. And if you do the math, 2 plus 6 is 8, 8 divided by 2 is 4. And now to find the y value of the vertex, we just plug it into the original equation as usual. Plug 4 in. So just to be clear, I got that 4 from there. And so Vy is equal to -2 times -2. And so we get +4, it looks like. So the vertex is 4, 4. Step 2, we're going to find the y-intercept. And to find the y-intercept, as usual, we let x equal 0. And we plug in 0 to the original equation. And just to be clear, I got that 0 from here. So now we have -2 times -6, and that's going to be -12. So the y-intercept is 0, -12. So now we're going to find the x-intercepts, which is going to be really easy. In fact, I probably can just do it down here. So the x-intercepts are going to be easy to find because the equation is in intercept form. So we can see it's just 2, 0, and 6, 0. All right, so I'm going to go ahead and plot those intercepts, those x-intercepts, 2, 0, and 6, 0. And the vertex was 4, 4, which would be here. And the y-intercept was 0, -12. This is all stuff that we figured out doing the math. Okay, so now we can just plot the, or draw the parabola. And we can use symmetry to find where approximately where the graph would be. It would be about here. So we want to make sure our graph goes through there just so the parabola looks right. And so now we're just going to draw the line of symmetry. And you always want to use a dotted line. I don't think I mentioned you want to use a dotted line just so it doesn't look like it's part of the actual graph. And the equation is x equals 4 because it's the the x is always equal to the x value of the vertex when you're writing the equation of the line of symmetry. So there you go. That's another example. So I'm going to leave number 10 in the window. I want you to go ahead and try number 11. And remember, I want you to find the x-intercepts, the y-intercept, and the vertex. And draw the line of symmetry and write the equation of the line of symmetry. So go ahead and try number 11. And when you come back, we'll do it together. All right, we're back. So we're going to start out by writing the constants. And then we're going to find the most important point on a parabola, which is the vertex. And to do that, we're going to use that special formula. And we get -6 divided by 2, which is -3. And to find the y value of the vertex, we just plug in the x value of the vertex, which we just found, to the original equation. So just to be absolutely clear, we got that -3 from there. Okay, and then we're just going to do the math, and we get -2 times +2, which is -4. So the vertex is -3, -4. All right, now on to step 2, we're going to find the y-intercept. And to find the y-intercept, as usual, we're going to let x equal 0, and then plug in 0 to the original equation. So y is equal to 0 plus 1 times 0 plus 5. And just to be absolutely clear, I got that 0 from there. And you can see then y is equal to 5, or I'm just going to show the steps. 1 times 5, which is 5. So the y-intercept is 0, 5. It's kind of a big comma there. All right, step 3, we're going to find the x-intercepts, which again is going to be really easy because the equation is in intercept form. So we see that the intercepts are just going to be -1, 0, and -5, 0. It's always the opposite signs of these. It's always going to be, you know, if it's +1 and +5, it's going to be -1 and -5. Okay, so -1 and -5, those are the x-intercepts. Now I want you to label all these points. If I didn't mention that, I do want you to label all these points. Label the coordinates, or write the coordinates of the points on the graph. So the vertex is -3, -4. That's here. And the y-intercept is 0, 5. That's up here. And so now we just have to connect the dots and make our parabola. Now we could plot more points just to make sure it's accurate, really accurate. For example, this parabola should go through this point here, but you know, I really don't care about being quite that accurate. It's, you know, as long as you get the main point. Okay, so now let's draw the line of symmetry, which as usual goes through the vertex. And again, the reason we're using a dotted line is that it distinguishes the line of symmetry from the actual graph, the green part. And the equation is x equals -3, so if you got those answers, good job. All right, and I want you to try number 12 now, and I'm going to leave number 10 and 11 in the window. So remember, label all those coordinates, find the x and the y intercepts, and draw the line of symmetry and the equation of the line of symmetry. So try number 12, and when you come back, we'll do it together. All right, we're back. So first, let's write the constants. And step 1, as usual, is to find the vertex, the most important point of a parabola. But to do that, we first have to find the x value. And we use that special equation. 2 plus 4 is 6. 6 divided by 2 is 3. Then we want to find the y value of the vertex. So we plug the x value of the vertex that we just found into the original equation. So just to be absolutely clear, I got that 3 from there. And -2 times 1 times -1 is equal to +2. And so the vertex is 3, +2. Now we're going to find the y-intercept. To do that, we're going to let x equal 0. And then we're going to plug in 0 to the original equation. And just to be absolutely clear, I got that 0 from there. And so we get -16, it looks like, when we do the math. I'll just show the steps there, though. So the y-intercept is 0, -16. The y-intercept always has an x value of 0. Okay, so now we're going to find the x-intercepts. And to do that, we're going to let, well, we're just going to look at the equation. We can see 2, 2, 4, because it's in intercept form. Let's go ahead and plot those. So 2, 4. And the vertex is going to be 3, 2. And the y-intercept we found is 0, -16. So that's about here. Okay, now we're ready to connect the dots. And we're probably going to need to use symmetry to find another point over here so our parabola doesn't look weird. So that's going to be right about here. So I'm going to look for that point. I'm not going to make you actually write the coordinates of that point, but we're just using it for reference. All right, now we're going to plot the line of symmetry and write the equation of the line of symmetry, which is x equals, what is the x value of the vertex? That is 3. So there you go. So if you got those answers, good job. Okay, so let's try the next one together. What's going to be different about this problem is the vertex is going to be the same point as the y-intercept. So you'll see as we go along here. Let's label constants. And of course we're going to find the vertex first. The x value of the vertex specifically. And then we get 0 over 2, which is 0. Any fraction with 0 in the numerator must be 0. Then we're going to find the y value of the vertex by plugging in the x value into the original equation as usual. And we get 1/3 times 2 times -2. And then we get 1/3 times -4. And, you know, a lot of students that really didn't learn everything they were supposed to learn in arithmetic, they would have problems with this. Whenever you multiply a whole number by a fraction, you just multiply the whole number into the numerator. So -4 times 1 is -4, and you're done. But students may have anxieties about basic arithmetic, even though at this point you're supposed to know this stuff already. In case you forgot, remember you can always write a whole number as over 1. So then it just becomes 1/3 times -1, or 1/3 times -4 over 1. And just multiply straight across. 1 times -4 is -4, and 3 times 1 is 3. Most teachers would not show you that. They would just say, sorry, you should know that by now. Now we have a improper fraction, and it's probably going to be useful to change it to a mixed number. So that's going to be -1 and 1/3. And if you forgot how to do that, again, you can go to my arithmetic course. So now we have the vertex. It's 0, -1 and 1/3. And step 2 is to find the y-intercept. To do that, of course, we let x equal 0. But you know what? Like I said, the vertex is the y-intercept. You see, because we found the x value of the vertex is 0. So we don't really need to do anything. We know we already have the point. It's right here. That's the y-intercept. So we can just rewrite it. It's 0, -1 and 1/3. That's the y-intercept. And obviously step 3 is really easy, again, because our original equation is in intercept form, meaning that we can see the x-intercepts. It's just going to be -2 and 2. So let's go ahead and plot those x-intercepts. -2 and 2. And the vertex is 0, -1 and 1/3, which is about here. And that is 2, 0 and -2, 0. So we found the x-intercepts and we found the y-intercept, which happens to be the vertex itself. And now we're ready to connect the dots. Now again, we could plot more points to have a more accurate graph up in these regions, but I don't really care about that. The most important thing is you get the basic idea of how to graph these parabolas. This is not an art class or an architecture class or an engineering class. You know, it's not a civil engineering class where everything has to be precise. Okay, so now let's draw the line of symmetry, which is going to be right on the y-axis. And we have x is equal to 0. That's the equation of the line of symmetry. Okay, so that was a special case where you know, the actual vertex happened to be the y-intercept. So I want you to go ahead and take a screenshot of this, because you're going to do a problem just like this one. And that's going to be number 14. So go ahead and try number 14, and when you come back, we'll do it together. All right, we're back. So we're going to label constants. And of course, the first step is to find the most important point of a parabola, the vertex, and we're going to find the x value of the vertex first using that special formula. So we have 1 plus -1 over 2, which is equal to 0 over 2, and any fraction with 0 in the numerator is 0. As long as there's not a 0 in the denominator, then things get more complicated. And then we're going to find the y value of the vertex by, of course, plugging in the x value to the original equation. And just to be absolutely clear, I'm getting that 0 from there. So the y value of the vertex is equal to -1/2 times -1 times 1. And you can see that that's just going to be +1/2. Okay, now step 2, we're going to find the y-intercept. To do that, we're going to let x equal 0. But you can see that, oh, by the way, we forgot to write the coordinate of the vertex. So the vertex is 0, 1/2. So you can see that if we let x equal 0, we're just going to find this point here. That's the vertex. So the y-intercept is the same point as the vertex. And step 3 is to find the x-intercepts. And because that equation up there is in intercept form, we can see the x-intercepts, 1, 0, and negative 1, 0. Let's go ahead and plot those x-intercepts, negative 1, 0, and 1, 0. And the vertex is 0, 1/2, which is there. And that's it. So we could plot more points, like I said, to make the parabola more accurate, but I'm not going to make you do that. Let's see here. I think it might be a little wider like that, but again, I don't really, it's not a big deal. Yeah, we should probably move this coordinate out of the way. You don't want your coordinates running into the graph. And let's draw the line of symmetry. It goes right through the vertex, and the equation of the line of symmetry is x equals 0. So if you got those graphs, or that graph, good job. Okay, so on to number 15. We're going to try this problem together. Something different is going to happen here. In this case, what we're going to find is that, notice that these values are the same. So there's going to be only one x-intercept. So it's going to look something like this. It's going to touch the x-axis once, which means that the x-intercept, the only x-intercept, is going to be the vertex also. So there's only going to be one x-intercept, and that x-intercept is also going to be the vertex. It's the same point. So first we're going to label constants as usual. And notice m and n are the same. And then we're going to find the x value of the vertex as usual, using that special formula we use for intercept form. 3 plus 3 is 6. 6 divided by 2 is 3. And then we're going to find the y value of the vertex using the original equation. So we have 3 minus 3 times 3 minus 3. And that is negative 2 times 0 times 0, which obviously would be 0. So the vertex is 3, 0. Step 2, we're going to find the y-intercept. To do that, we let x equal 0. Whoops. So let's plug 0 into the original equation. And we get y is equal to negative 2 times 0 minus 3 times 0 minus 3. And just to be absolutely clear, we got this 3. Whoops, that should probably be yellow. We got that 3 from there, and we got this 0 from there. Do the math, and we have negative 3 and negative 3. And that's going to be negative 18. So the y-intercept is 0, negative 18. And the x-intercepts, we can see very easily just by looking at the original equation, because it's in intercept form, which means that we know the x-intercepts. And the x-intercepts are going to be the same. This is going to be one x-intercept, 3, 0, and 3, 0. We don't really have to write it twice, but I'm just writing it twice so you can see that they're the same. So what that means is that the parabola only touches the x-axis once, And the y-intercept we found down there is 0, negative 18. So that's going to be here. And then looks like we're gonna have to use symmetry to find another point. Looks like that's gonna be about here. That'll just give us a guide. And this point, the vertex is 3, 0. And then we can just connect the dots. I didn't really center that very well, but again, this is not an art class, as long as you get the main idea. Now let's draw the line of symmetry. And the equation is x equals 3, the x value of the vertex. Alright, so again, the difference with that problem is that there was only one x-intercept, and whenever you have that situation with a parabola that opens up or down, the one x-intercept is going to be the vertex also. So I want you to try number 16. That's going to be a very similar problem. And I'm going to leave 15 in the window. So try 16 at the bottom left, and when you come back, we'll do it together. All right, we're back. So we're going to label constants as usual. And of course, we're going to find the most important point on a parabola, which is the vertex. And to do that, we're going to first find the x value of the vertex, and we're going to use that special formula. And we get negative 4 over 2, which is negative 2. Then we're going to find the y value of the vertex by plugging in the x value of the vertex into the original equation. And we get 3 times 0 times 0, which obviously is 0, so therefore the vertex is negative 2, 0. Okay, and step 2, we're going to find the y-intercept. And to do that, obviously, we're going to let x equal 0, and then plug in 0 to the original equation. So y is equal to 3 times 0 plus 2 times 0 plus 2. And just to be clear, I got this negative 2 from there, and the 0 from here. So we have 3 times 2 times 2, which is 12. And so the y-intercept is 0, 12. All right, now we're going to find the x-intercepts. Again, finding the x-intercepts is really easy because our original equation is in intercept form, so we know that the x-intercepts are the opposite of those signs, so we have positive 2 on those, so it's going to be negative 2, 0, and negative 2, 0. Now again, you don't really have to write it twice, because it's only one point, but I'm just drawing attention to the fact that they're the same. So negative 2, 0 is there. And the vertex is negative 2, 0, so that's the same point, and the y-intercept is 0, 12, which would be up here. And to make the graph look somewhat accurate, we're going to have to use symmetry, so we go out 1, 2, 3. Actually, no, we're just going out 1, 2 to the vertex, so we'll go out 1, 2 more to get to that next point there. So that just gives a reference point. I'm not going to require you to write the actual coordinates. All right, so connecting the dots. And then we're going to write or draw the line of symmetry, which always goes right through the vertex. And of course, the equation of the line of symmetry is x equals the x value of the vertex, negative 2. So if you got that answer, good job. Okay, so let's try number 17. On to something else. Now, in every problem that we've done so far, we've used intercept form. This doesn't look like intercept form right here. That looks like standard form. And it is standard form. You know, it's ax squared plus bx plus c. In this case, a would be 3, b would be negative 12, and c would be 0. And you could use standard form to graph this. Then you would have to use the old formula that we've used, negative b over 2a, to find the x value of the vertex. But we're not going to do that because there's an easier way to do it. What we could do is we could factor out the greatest common factor, our greatest common monomial. You know what? I'm going to change this to plus. I just prefer that to be a plus problem. So I'm going to factor out 3x. And, you know, this is something that really upsets students. They don't like that. They don't like that I could factor out a 3x like that. A lot of students, they get angry by that. They say, how in the world did you do that? Well, to understand why that works, and by the way, we learned this in my beginning algebra course. This is, you know, something at the very beginning of the course. You can go to factoring a greatest common factor, or part 1 of factoring, I believe it is, in my beginning algebra course. And but in order to understand why this works, you just take 3x and you use the distributive rule. 3x times x is 3x squared. 3x times 4 is 12x. Okay, again, 3x times x is 3x squared, and 3x times 4 is 12x. So just going backwards, you can see why that works. So factoring is the reverse direction of multiplying using the distributive rule. Now you might be thinking, well, who cares? Why do we do that? What's the point? Well, if I change x to x minus 0, and I can do that, right? Isn't that legal? Isn't it true that x minus 0 is the same thing as x? If you subtract 0 from something, it doesn't really change it. So what I did is I changed x to x minus 0. And you might still be thinking, well, who cares? What's the point? Well, the point is this now looks like intercept form. And so we're going to do this problem the same way we did all the other problems previously. So we label constants, and we just continue as we did in the previous problem. So we're going to find the x value of the vertex using that same old formula given intercept form. Now again, it's very important to understand this is not intercept form. This is intercept form. All right. So we're plugging in those numbers, and we get negative 4 divided by 2, which is negative 2. And now we're going to find the y value of the vertex, plugging in that value into the original equation. Now I'm going to plug it into this equation because that's the easiest one to use. Whoops, got to get my red pen. So we have 3 times negative 2 times negative 2 plus 4. And again, just to be absolutely clear, I got that negative 2 from there. So the y value of the vertex is equal to 3 times negative 2 times positive 2, which is negative 12. So the vertex is negative 2, negative 12. All right, and step 2 is to find the y value, or excuse me, the y-intercept. And to do that, we let x equal 0 as usual. Again, these are all things that I require you to do in this particular class. So we're going to plug in x equals 0. So we have 3 times 0 times 0 plus 4. And again, I got that 0 from there. And of course, we have 3 times 0 times 4. Because we're multiplying by 0, our answer has to be 0. So therefore, our y-intercept is just 0, 0. Now we're going to find the x-intercepts. And when you try to find the x-intercepts, you need to look to the right equation, look to intercept form. That tells us where the intercepts are. It's going to be 0 and negative 4. So 0, 0, and negative 4, 0. Let's go ahead and plot those. 0, 0, and negative 4, 0. And now we're going to plot the vertex, which is negative 2, negative 12. And that's going to be all the way down here. And as you can see, in this particular problem, one of the x-intercepts is the same. It's the same as the y-intercept. It's where the graph crosses the y-axis. I'm going to move this over. So just connect the dots as usual. And draw the line of symmetry. And the equation of the line of symmetry is x equals negative 2. So the difference with this problem is that one of the x-intercepts was also the y-intercept. I want you to go ahead and, you can take a screenshot of that if you need to, because you're going to do a problem that's very similar to that. I want you to go ahead and try number 18. Now remember, the first step is to factor out the greatest common factor. What is common to both these terms? And if you need help with that, you can go back to my beginning algebra course, or you can just go to the previous problem. And I want you to solve this by converting this to intercept form. That's just the way that it's the easiest way to do it. So go ahead and try number 18, and when you come back, we'll do it together again. Take a screenshot of the previous problem if you haven't done that. All right, and when you come back, we'll do this problem together. All right, we're back. So I'm going to factor out the greatest common factor, which is x. If you factor it on x, you're right. Now, why does that work? Because x times x, if you use the distributive rule and go backwards, x times x is x squared. And x times negative 6 is negative 6x. That's why I know that I factored correctly. Now I'm going to change x to x minus 0. Excuse me. So just to be clear, I changed x to x minus 0. And now we're in intercept form. So now we can label the constants, just like we did in previous problems. And step 1 is to find the x value of the vertex as usual. We have 0 plus 6 over 2, which is 3. And then we find the y value of the vertex by plugging into the original equation. Now I'm going to use this equation. That's easier than the original equation, actually. So we have 3 times 3 minus 6 equals y. Just to be clear, I got that 3 from there. And we have 3 times negative 3. Whoops, why did I write y equals y? I don't really need that. And so that's going to be negative 9. And so the vertex is 3, negative 9. All right, step 2, we're going to find the y-intercept. And to do that, obviously, we're going to let x equal 0 as usual. So I'm going to go to that easy form of the equation and plug in 0. So we have 0 times 0 minus 6 equals y. And you can put y on either side. I think in the previous problems I've been putting y on the left side. It doesn't really matter. You can flip it around however you want. So then we have y equals 0 times negative 6, which is obviously 0. So therefore the y-intercept is 0, 0, just like in the previous problem. Okay, and now we're going to find the x-intercepts, which is going to be easy to do simply because we put this equation into intercept form, which means we can see the intercepts just by looking at it. It's 0, 0, and 6, 0. Okay, so I'm going to go ahead and plot those. 0, 0, and 6, 0. And the vertex is 3, negative 9. 5, 6, 7, 8, 9. That's 3, negative 9. And so we found the x-intercepts and the y-intercept, which just happens to be the same as, the x-intercept. So now we're going to connect the dots. Again, this is supposed to be a little more rounded, but my parabolas look a little bit too much like V's, but you get the point. Okay, so now we're going to draw the line of symmetry and draw the equation of the line of symmetry, and there you go. So if you got those answers, good job. Okay, so now we're going to go on to vertex form. We're done with intercept form. So for vertex form, again, you should have taken a screenshot of all these, but vertex form is going to be this form down here, and this is the x value of the vertex, this is the y value of the vertex. So that's very useful because we can see the vertex just by looking at the equation. So first of all, let's label constants. So a is 4, h is negative 2. Remember, you change the sign. Change the sign of that value there. But this value here, you keep it. You keep the sign. Don't change it. I know that's kind of hard to remember, but just remember it. You either remember it or you don't. It's pretty simple. Okay, so now step 1 obviously is to find the vertex. Now the x value of the vertex is h, which is negative 2. Now you might think, well, why don't we just call it vx? Why do we have to call it h? We're changing this up. It's making it more complicated. Well, it's just traditionally called h in vertex form. So that's just the way mathematicians have decided to do it. So the y value of the vertex is k, which is negative 4. So the vertex is negative 2, negative 4. So that's the easiest part, is finding the vertex because it's in vertex form. Now we're going to find the y-intercept. And to do that, obviously, we're going to let x equal 0 as usual, and we're going to use the original equation to find the y value, or the y-intercept. So we plug in 0 for x. And just to be absolutely clear, I got that 0 from there. So we have, using PEMDAS, you don't really have to show this. I'm going to show it just because I want to give you a little bit of review, but PEMDAS is really something you should know by now. Remember, parentheses first, then exponents, then multiplication, then division, then addition, then subtraction. And so we get 16 minus 4, which is 12. Therefore, the y-intercept is 0, 12. Remember, the x value of the y-intercept is always 0. That's how we find it. Now we're going to find the x-intercepts. And to do that, we let y equal 0. Now, in the previous problems, we didn't write this because, it's just understood that if we have our equation in intercept form, we can see the x-intercepts. We don't have to go through this whole process of letting y equal 0 and so on and so forth. But in these problems, we do have to do that. So we're going to rewrite the original equation, but we're going to let y equal 0. So let me go ahead and do that. So y is now 0, in that original equation. Let me make sure I got that equation right. Looks correct. So now we have to solve this equation, and this is an equation with a square. So we're solving an equation with a square, and this is the square here. Now we did this in my beginning algebra course, and you can go back to my class in my beginning algebra course entitled Equation with Squares. I believe that's the title. And you have a whole class just teaching how to solve these types of problems. But we also reviewed this in this course earlier. I don't remember exactly what class, but to solve this, all you have to do is just isolate this square, get it by itself. It's not by itself because the -4 and the 4 over here are next to it. So we have to get rid of that -4 and the 4. So to get rid of this -4 over here, I'm going to add 4 to both sides. And then I'm going to divide both sides by 4. And then we're going to go up here because we're out of room. At that point, I've isolated the square. The square is now isolated. It's by itself. So now what I have to do is I have to get rid of that 2. Because I want to isolate this x. I want to get the x by itself, but I can't get inside there unless I get rid of this 2 first. So to get rid of that 2, we're going to do the opposite of squaring. The opposite of squaring is square rooting. And remember, whenever you square root, you have to put a plus or minus on one side of the equation. Again, we're getting rid of this square here by square rooting, which is the opposite of squaring. Okay, and so that gets rid of the square. Now we're just left with x plus 2, and we don't really need the parentheses. And the square root of 1, what number times itself is equal to 1? Well, there's only one number that fits that description, 1. So now we're going to isolate x. X can be equal to, or actually let's do one more step here. So we're going to subtract 2 from both sides, so we get -2 plus or minus 1. And now we're going to break it up into 2 equations. So x can be -2 plus 1, or x can be -2 minus 1. So it would be -3, or it would be -1. So what does that mean? It means that the x-intercepts are -1, 0, and -3, 0. So we found the x-intercepts. Okay, so let's go ahead and plot the x-intercepts, -1 and -3. And the y-intercept is 0, 12. And the vertex is -2, -4. And now we can just connect the dots. So this is kind of a narrow parabola. And now we're going to plot the line of symmetry and write the equation of the line of symmetry, which is x equals -2. All right, so we graphed a quadratic expression in vertex form, and we found the x-intercepts and the y-intercept. Okay, so let's do one more of those problems before you try one on your own, down to number 20. So this is in vertex form, so let's go ahead and label the constants. H is going to be the opposite sign, and it doesn't appear that there is a k. Where's the k? It's not there. Well, if it's not there, it's just considered to be 0. In fact, let me go ahead and write that in vertex. I mean, it's already in vertex form, but I just want you to see exactly what's going on here. So plus 0 equals y. So this is h, and this is k. All right, but h is going to be the opposite sign. So h is the opposite sign, and k stays the same sign, but since it's 0, it really doesn't have a sign. And so first step is to find the vertex, and that's going to be really easy because the x value of the vertex is equal to h, which is equal to -5, and the y value of the vertex is equal to k, which we found is 0. So the vertex is -5, 0. Now let's find the y-intercept. In order to do that, as usual, we let x equal 0. And we can plug that into the original equation. So y is equal to 1/3 times x is 0. And just to be absolutely clear, I got that 0 from there. So now we just follow order of operations. We do the parentheses first. 0 plus 5 is 5. And then we do the exponents. 5 squared is 25. And we're multiplying a whole number by a fraction. So that's just 1/3 times 25 over 1. 25 times 1 is 25. 3 times 1 is 3. Again, most math teachers at this level will not show you that. They'll just expect you to know how to do that. All right, 25 over 3. And just for graphing purposes, let's go ahead and change that to a mixed number. So 3 goes into 25 8 times. The remainder is 1. And so the y-intercept is 0, 8 1/3. Okay, so now we're going to find the x-intercepts. And to do that, we're going to let y equal 0. And we're going to plug in 0 into the original equation. And maybe I should have notated, actually I did notate that. In fact, just to make it easier, I'm going to bring this down here, I guess. I guess that doesn't really do anything. I'm going to try to show here that I'm using this original equation. So we have 1/3 x plus 5 squared equals 0. I'm plugging in 0 there to find the x-intercepts. Remember, when you want to find the y-intercept, you let x equal 0. When you want to find the x-intercept, you let y equal 0. So that's what we're doing. Okay, at this point, there's a lot of different things you can do to isolate the square. You know, we have to get this square by itself. It's not by itself because the 1/3 is next to it. So how do we get rid of that 1/3? Like I said, there's a lot of different ways you could do this. You could multiply by 3. That would get rid of it pretty quickly. But probably the easiest way for you to understand is just to divide both sides by, 1/3. I'm going to color that a different, just so you can see there. We're dividing both sides by 1/3. And 0 divided by any number is just 0. So we have 0 is equal to x plus 5 squared. And then we're going to square root both sides, as we did in the previous problem. Of course, you always have to write plus or minus. And to save some room here, I'm going to bring this down. And I'm going to carry this line out like that. Okay, so now we have x plus 5 is equal to plus or minus 0, but plus or minus 0 is just 0. So we have x plus 5 is equal to 0, and subtract 5 from both sides, and we get x is equal to -5. And what that means is that in this particular problem, there's only one x-intercept, and it's -5, 0. So what that means is that the x-intercept is going to be the vertex right here, -5, 0. And the y-intercept is 0, 8 1/3. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 1/3. Should be about there. 0, 8 1/3. And we're going to have to use symmetry, so we go out 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Because we need another reference point there, so then we can connect the dots. Whoops, wrong color. And we're going to draw the line of symmetry as usual. And write the equation of the line of symmetry, which is x equals -5. So that's just another example where we're graphing a quadratic expression in vertex form, but we're finding the x-intercepts and the y-intercept. Okay, so I'm going to leave number 19 and number 20 in the window, and I want you to try number 21. And remember, you're going to get to a point where you have to solve an equation with a square. And to do that, you have to isolate this square. You have to get it by itself. So in this case, we had to get rid of the 4 here and the 4 here. And then once you've done that, then you have to square root both sides and so on and so forth. So go ahead and try number 21. And when you come back, we'll do it together. All right, we're back. Okay, so first we're going to label constants. And of course, the first step is to find the to find the vertex in general. So the vertex is, or the x value of the vertex is equal to h, which we found is 1. And the y value of the vertex is equal to k, which we just found is -8. And maybe I should move that over a little bit. Okay, so what that means is that the vertex is 1, -8. So again, because it's in vertex form, we can easily find the vertex, the most important point of the parabola. Now we're going to find the y-intercept. And to do that, obviously, we'll let x equal 0 as usual. So we're going to let x equal 0 in the original equation. And just to be absolutely clear, we got that 0 from there. And so following PEMDAS, we want to do parentheses first. So we get 0 minus 1 is -1. Then we do exponents. -1 to the second power is +1. And 2 times 1 is 2. And 2 minus 8 is -6. So what does that mean? It means that the y-intercept is 0, -6. Now we're going to find the x-intercepts. In the previous problem, there was only one x-intercept, but in this problem, there's going to be 2. So to do that, we let, again, to find the y-intercept, we let x equal 0. To find the x-intercepts, we let y equal 0. So we're going to let y equal 0, and we're going to plug that into the original equation. So we have 0 is equal to 2 times x minus 1 squared minus 8. Okay, so again, we let y equal 0, and now we have to solve. This is an equation with a square. We have to isolate this square, you see. It's not isolated because the 2 and the -8 are next to it. So we're going to add 8 to both sides. We're going to divide both sides by 2. Wait a second, I'm sorry, that 8 shouldn't be there. Got rid of that 8. And then we're going to square root both sides. But we're out of room. Remember, whenever you're out of room, you have to draw a little arrow going up there. So we're going to square root both sides, and whenever you do that, you have to write plus or minus. And I should probably write that a little more legible. Okay, what number times itself is equal to 4? Well, that's going to be 2. And then add 1 to both sides, and we get 1 plus or minus 2. So x can be 1 plus 2, which is 3. And I guess I don't really need to write that intermediate step. Or x can be 1 minus 2, which is negative 1. So what does that mean? It means the x-intercepts are 3, 0, and negative 1, 0. Okay, so let's plot those points. Negative 1, 0, and 3, 0. And the vertex is 1, negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. It's down there. And the y-intercept is 0, negative 6, so it's about here. And now we can just connect the dots. All right. And let's plot the line of symmetry. Remember, for all these problems, I'm going to require you to plot the, draw the line of symmetry. And the equation of the line of symmetry is x equals 1. Okay, so if you got that graph, good job. And I'm going to leave those problems in the window, and I want you to try number 22, the last problem of the day. So remember, you're going to get an equation with a square. You're going to have to solve that equation by isolating the square when you find the x-intercepts. So go ahead and try number 22. When you come back, we'll do it together. All right, we're back. So first I'm going to label constants. Remember, the sign changes here, but it doesn't change for the y value of the vertex. And so now we have the vertex, or the x value of the vertex is h, which is 3. And the y value of the vertex is k, which is 9. So now we have the vertex. It's 3, 9. Now we're going to find the y-intercept. To find the y-intercept, we let x equal 0. And plug that into the original equation. And using PEMDAS, order of operations, we do parentheses first. 0 minus 3 is negative 3. And negative 3 squared is positive 9. And of course, negative 9 plus 9 is 0. You don't really need those parentheses anymore on the 9. So the y-intercept is 0, 0. All right, so now we're going to find the x-intercepts. And to do that, we're going to let y equal 0 and plug in 0 for y in the original equation. And just to be clear, this 0 came from there. So letting y equal 0, we have 0 is equal to negative x minus 3 squared plus 9. So now we just have to solve that equation. And that equation is an equation with a square. We have to isolate that square first by getting rid of this negative and the 9. So we're going to subtract 9 from both sides. That gets rid of the 9 on the right side of the equation. And then we're going to divide both sides by -1 to get rid of that negative there. And we end up with 9 is equal to x minus 3 squared. So now we want to get rid of that second power, so we're going to do the opposite of squaring, which is square rooting. And remember, you always have to put plus or minus on this other side here when you square root both sides of an equation. Okay, so now we're out of room. So instead of panicking, we're just going to go up here. What number times itself is equal to 9? Well, that's going to be 3. 3 times 3 is 9. And then we get x minus 3, so now we're going to add 3 to both sides, and we get 3 plus or minus 3. So if 3 is positive, we have 3 plus 3 is 6. And if 3 is negative, we have 3 minus 3 is 0. So what does that mean? It means one x-intercept is 6, 0, and the other intercept is 0, 0. All right, so let's plot those intercepts, 6, 0, and 0, 0. We have 0, 0, and 6, 0. And the vertex is 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 0, 0 is obviously the y-intercept also. So we can just connect the dots. All right, now let's draw the line of symmetry and write the equation of the line of symmetry, which is x equals 3. So if you got that graph and you plotted all those x-intercepts and the y-intercept, and you drew the line of symmetry and the equation of the line of symmetry, good job. Okay, now we're going to do a problem where the graph does not have any x-intercepts. So let's label the constants first because we still have a vertex form. And first step, as usual, is to find the x value of the vertex, which is h, which is 1. And the y value of the vertex is k, which is 12. So we know that the vertex is 1, 12. And step 2, we're going to find the y-intercept. And to do that, we're going to let x equal 0 in the original equation. So I have y equals 3 times 0 minus 1 squared plus 12. And just to be clear, I'm taking that 0 from there, plug it in there. And we get 3 times negative 1 squared plus 12. Negative 1 squared is 1. And then we have 3 plus 12. Which is 15. So the y-intercept is 0, 15. Now we're going to find the x-intercepts. And what we're going to find is that there are no x-intercepts. Now remember, to find the x-intercepts, you let y equal 0. Well, first of all, let me label what we're doing here. So we're finding the x-intercepts. And we're going to let y equal 0 in the original equation. So we're going to rewrite that equation, except plugging in 0 for y minus 1 squared plus 12. So just to be clear, I got that 0 from there because we're letting y equal 0. So now we have to solve this equation, and of course we have to isolate the square. So we have to get rid of the 12 and the 3. So we're going to put the 12 on the other side. And then we're going to divide both sides by 3, and we get negative 4 is equal to x minus 1 squared. And at that point, we can really stop. We don't really need to go any further because we know that you cannot square a number and then have that equal a negative number. You can't square something to get a negative number. It's impossible. But just to show you what's going to happen here, I'm going to actually continue with the algebra. So we need to get rid of the second power there. So just like we did in the previous problems, we're going to square root because that's the opposite of squaring. And you always have to put plus or minus. Remember, whenever you have a negative inside a square root, the negative just comes out as I. And square root 4, that's just 2. So that's going to end up being 2i. You know, and you can pull out the I first. I mean, however you want to do it, so it you know, makes sense to you. But usually the 2 is written first. You don't really have to write all these steps. In fact, you don't have to do any of this, like I said, because once you get to this point, you know you can't square a number and get a negative number, so there are no x-intercepts. But if you continue to solve, you end up with 1 plus or minus 2i for x. So that means that x can be 1 plus 2i, or x can be 1 minus 2i, but both of these numbers are complex numbers. If you get complex numbers for the x-intercepts, then what that means is there are no x-intercepts. So you really don't have to do all this stuff. So what I'm going to do is I'm going to try to indicate here that you can stop. I'm going to put a big old stop word there, meaning you don't really have to do all this stuff. So our conclusion is that there are, I don't really have a lot of room to write, but I'm just going to say up here, no x-intercepts. I don't really have any room really to write that. I'm going to move this over a little bit. So no x-intercepts. Okay, so we still need to graph the parabola though. So 112, that's going to be here. That's the vertex, and our y-intercept is 0, 15. So 11, 12, 13, 14, 15. And that was 112. And we can use symmetry to connect the dots there. So as you can see, this parabola doesn't go through the x-axis. And therefore, of course, it doesn't have x-intercepts. We still need to draw the line of symmetry, though, and write the equation of the line of symmetry, which is x equals 1. So there you go. That's an example where there are no x-intercepts, but there is still a y-intercept. You see here, this is the y-intercept. So you can take a screenshot of that if you want. Well, actually, I'm just going to leave it in the window, and I want you to try number 24. Just be aware that when you do number 24 and you're trying to find the x-intercepts, you're going to get to a point where your square is equal to a negative number. And when you get to that point, you can just stop. You don't have to show all this stuff here. Okay, you can just stop and conclude that there's no x-intercepts. So go ahead and try number 24, and when you come back, we'll do it together. All right, we're back. So we're going to label constants. This is still vertex form. Obviously, we're going to find the x value of the vertex as usual. And so the vertex is obviously -1, -18. Step 2 is to find the y-intercept. And to do that, we let x equal 0 as usual and plug that into the original equation. So we have -2, 0 plus 1 squared minus 18 is equal to y. And we have -2 times 1 squared minus 18 is equal to y. 1 squared is 1. And -2 times 1 is -2. And so y is equal to -20. So our our y-intercept is 0, -20. Now we're going to find the x-intercepts, and what you'll find is that there are no x-intercepts, but we're going to let y equal 0. So we have -2x plus 1 squared and minus 18 equals y, but we're going to let y equal 0. And just to be clear, plug in 0 there. And also I plugged in this 0 here. So now we just have an equation with a square. I'm going to put the 18 on the other side. And then I'm going to divide both sides by -2. And you get -9. So at this point, you don't really have to continue. You can stop right there, because you know that there are not going to be any x-intercepts, because you can't square a number and get a negative. So that means that the solutions are going to be complex solutions. And that just means, again, there's no x-intercept. So let's go ahead and graph what we can. So -1, -18, that's going to be down here. Whoops, that's on the other side actually. -1, -18. And let's graph the y-intercept. The y-intercept is 0, -20. And of course we can use symmetry. Sorry, these graphs ended up being kind of small, or the parabolas ended up being kind of small. But as you can see, this parabola is just going to keep going down this way. It's never going to touch the x-axis. So that's an example where the graph, again, didn't have any, the parabola didn't have any x-intercepts. So if you got that graph, good job. So let's go ahead and take screenshots of all of the work that we did today. Actually, I forgot to write the line of symmetry. So x equals -1 is the equation of a line of symmetry. Alright, let's take screenshots of all the work that we did today to help you with your homework and to study for tests. So here's screenshot number 1 and screenshot number 2 and screenshot number 3 and number 4 and number 5 and number 6 and number 7 8. And number 9. And number 10. But don't go before you get your homework. Let's take a look at the homework. So here's the homework. Get a screenshot of these first 2 pages. And get a screenshot of these pages. These are the answers for problems numbers 1 through 8. And get a screenshot of these last pages. These are the answers for problems 9 through 16. And when you do the homework, be sure to follow these directions carefully. For each problem, I want you to find the y-intercept and the x-intercepts if there are any. And of course, draw the line of symmetry and write its equation. And when you graph these parabolas, I want you to use grid paper. That's the paper with these blue squares. You don't really have to use grid paper, but it's just going to make things a lot easier. And as always, label your x-axis and your y-axis. And just as like we did in class, I want you to write the coordinates of each point that you plot. And of course, your homework has to have 4 characteristics. It has to be complete, correct, neat, and in chronological order in your binder. And remember, if you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. I know you're probably getting tired of me saying that, but the purpose of this course, as well as any other math course, is to learn fluency in the material covered. And if you don't do the homework, that's not going to happen. So get that homework done, and I'll look forward to seeing you in the next class.